So Pi Day was around a week ago, and I haven't seen anything like this on YouTube. So I'm going to show you how I derive the value of pi. Now note, we can't use sine functions, we can't use radial arcs or anything like that, because that depends on the value of pi. This is how to find pi without using the value of pi, or any function that requires it. So this is how we're going to do it. Consider the following regular polygons that have a distance. So regular just means same value for each side and angle, and the distance from a center to a vertex is 1. So this is four-sided. 3, 4, 5, 6, 7, 8. This is an 8-sided polygon, so that distance is 1 right there. We can have 16 sides, 32 sides, 2 to the n side, such that n is greater than or equal to 2. And we keep going until we have a perfect circle. See how that works? Just keep expanding this, and that's 1. What is the area of the circle? A right here is just equal to pi times 1 squared, which is equal to pi. Right? We know that. So if we can find the area of this polygon as it approaches infinity, we can derive a value for pi. So let's start off with a square and break it off into a triangle. So we know that there are 4 triangles in the square, each of the following composition. You have an angle right here, central angle, let's call that x, 1, 1. By the way, the reason why we're going powers of 2 is because this value of x halves, and we're going to use the half angle formula to find the following areas. Recall that the area of a triangle is equal to 1/2 AB sine C, where C is the angle nested between 2 sides A and B. However, A is also equal to base times height. So the A for this triangle is simply equal to 1/2 base times height over 2 times 1 times 1, which is equal to 1/2, which is also equal to 1/2 times 1, so just 1/2, times sine of x. So that gives you sine of x is equal to 1. So this central angle has sine 1. What can we find about the sine of the next iterations? Well, we can use the double angle formula and derive a half angle formula. One thing to note is all our angles are less than or equal to 90 degrees, so we don't need to consider all possibilities. So we know that sine 2 theta for any theta is equal to 2 sine theta cos theta. Since we're using half angles and we're only dealing with acute angles, we can rewrite this as sine theta is equal to 2 sine theta over 2, square root of 1 minus sine squared theta over 2. Now, in order to proceed from here, we simply just need to rearrange the equation. So, squaring all the sides, we get sine squared theta, well, both sides, equal to 4 sine squared theta over 2 times 1 minus sine squared theta over 2. And we just square both sides. From here, we can just rearrange the equation just by distributing and adding and subtracting on both sides. I'm sure you all know how to do this. We get 4 sine to the 4th theta over 2 minus 4 sine squared theta over 2 plus sine squared theta equals to 0. Voila! Quadratic equation, we can find sine of theta over 2 in terms of sine theta. So we can get that sine theta over 2. Notice we just square root the entire thing because we're doing it to the 4th. So we have a big square root here. 4 plus minus the square root of 16b squared minus 4ac over 2a. Now, first thing we gotta say is this does not exist, because this value must be less than 1. Hence, this value must be less than 1. Well, between 0 and 1, because it's acute angles. So it has to be a minus here. Additionally, we can factor out the 16, we get a 4. And this is cosine, but we only have sine, so we're only going to use sine here. So this simplifies down to square root of, we cancel out here, square root of 1 minus the square root of 1 minus sine squared theta over 2. Let's go back to our polygons. So this right here has an area of, so the area of the triangle, so that's 1/2, we know AB is 1, 1/2 of the first iteration, which is 1, times 4 triangles, 2 squared. Iteration 2 has 8 sides, right? 2 cubed. So we have 8 sides 1/2 times square root of 1 minus square root of 1 minus 1 squared over 2 times 8 sides 2 cubed. If we keep going on like this, we're going to have a huge mess here. So let's define a function. The sine of the angle can be defined as Zn. For the nth iteration, the sine of the angle for the nth iteration. This is the first iteration, this is the second iteration, the third iteration is 16 sides, and so on. So, Z1, the first iteration, sine is just equal to 1. Zn, well, let's say Zn plus 1 is equal to the square root of, this is just going to be Zn. So, 1 minus the square root of 1 minus Zn squared over 2. So, let's rewrite this. This is of 1. This is going to be Z2. 16 sides is going to be Z3. So it's 1/2 Z3 times 2 to the 4th. So on. What do we notice? For the nth iteration, we get 1/2. This is n plus 1. 2 to the n plus 1 times Zn, which is simply equal to 2 to the n times Zn. And we have it. This is our formula. So let's just formally write this, because as n approaches infinity, we approach a circle with area pi. So what we can do here, we can say that pi is equal to the limit as n approaches infinity of 2 to the n times Zn such that Z1 is equal to 1, Zn is equal to, Zn plus 1 is equal to the square root of 1 minus the square root of 1 minus Zn squared over 2. 2 to the square root. And that right here is your definition of pi. Thank you for watching.